Pandas is a powerful Python library used for data manipulation and analysis. It provides two primary data structures, series and data frames. Understanding how to create and manipulate these structures is essential for data analysis tasks. Now, before we begin, we need to import the Pandas and NumPy libraries. NumPy is often used alongside Pandas for numerical operations. So we're going to start off with importing our pandas as PD, which is quite often abbreviated as, and we're going to import NumPy as NP. Oops, I meant NumPy as NP. Now we're going to start off with Pandas Series. A series is a one-dimensional labeled array capable of holding any data type, integers, strings, floating point numbers, Python objects, and many others. Each element in a series has an associated label which is known as its index. You can create a series from a Python list by passing the list to the pd.series function. So let's start off by creating a simple list of temperatures. And they're going to be, for example, 22, 28, 19, 24, and 30. Yes, they're Celsius instead of Fahrenheit. My apologies. And since we now have a list of temperatures, we can convert that into a series. And to do that, we will have temp series. So that's going to be a temperature series. And we're going to use pd.series. And here we're going to pass the temperatures. And if we want to take a look at the series that we have created and we hit play, then we see we have our series. And like I've mentioned before, each element has its predefined index assigned to each element within that series. Now, if you wanted to specify custom indices, you can provide them using the index parameter. So let's create a new list called days, and we're going to have Monday, Tuesday, Wednesday, Thursday, and Friday. Now, if we want to use those days as our custom indices for our temperatures, then we would do temp series, and we would use the pd.series function again, and again passing in the temperatures. And then this time we're going to have the index parameter. And here we're going to use the days as the index. And then once we have created that and we want to take a look at the temp series, then we can see here that instead of the number index for each element, we have assigned predefined days for each element. A series can also be created from a dictionary. The keys become the indices and the values become the data. So let's create a fruit counts dictionary where we're going to have 3 different types of fruits and basically a count or a counter for each fruit. So we have apples, and in our apples we have 10 of them. For bananas we have 15, and for cherries we have 17. So this is our fruit count dictionary. And now we can use this dictionary to create our series. So we'll have a fruit series, and we'll use the PD series method function again, and we'll pass in our fruit counts. And if we want to take a look at our fruit series, once we have created it, then we can see again, very similar as before with the days and temperatures, we have our apples, bananas, and cherries, so our fruits, which are our indexes, and the values, which are basically the data for each element. You can create a series also from a NumPy array in a very similar way. So using our NumPy library, we are going to create a list of random numbers. So we'll have random numbers, and we're going to use NP to generate some random numbers. And specifically, we're going to use the randn method function, and we're going to provide 5. And now we want to create our random series. And of course, again, pd.series function, and we pass in our random numbers. And once we want to take a look at our random numbers, and of course, a small misspelling. And there we go. We have 5 random numbers that we have created in our random numbers list. We pass it into our series, and we have our series of random numbers. Now that we've covered Pandas series, we can now jump into Pandas DataFrames. A data frame is a two-dimensional labeled data structure with columns that can be of different data types. It is similar to a spreadsheet or an SQL table, basically. You can create a data frame by passing a dictionary where the keys are column names and the values are list of column data. So let's start off by creating our dictionary, which is going to be called data, basically. And here we're going to provide the name and the age and the country of each person that's going to be in our data. So let's create a key called name. And here we're going to provide a list of names. So let's say Alice, Bob, Charlie, and David. Okay, next we're going to provide a list of ages. So we're going to have our age key and the list of ages. So let's say 25, 30, 35, and 40. And then a list of countries. So let's create our country key and our list of countries, which is going to be USA, UK, Canada, and Australia. Okay, great. Now, let's create a new cell here. And let's convert this into a data frame. So our data frame is going to be called a DF, which is quite often used as an abbreviation for data frames. And we are going to use the pd.dataframe function. And here we're going to pass in the data. And if we want to take a look at our data frame, this is how our data frame now looks like. And so like we have mentioned before, this is basically the name of each column, and under each column we have our list of values. So again, here we have our name, age, and country, which are our keys, and underneath are the list of values. Sometimes data is more naturally represented as a list of dictionaries, where each dictionary represents a row. So now let's try to create a data frame based off of a list of dictionaries. So let's create a new dictionary called data2. And we're going to create our list, which is going to be square brackets. And in that list, we have our list of dictionaries. So we'll have 2 or 3. And our first dictionary is going to have, of course, name key, which is going to have Emma, then age of 29, and country USA. And of course, quote there, comma, and let's take this and copy it, paste, comma, paste. Let's fix that formatting. And let's change the names here to Liam, Olivia, age 32 and 27, and UK and Canada. Okay, and in a very similar way, or actually exactly the same way, we create our data frame. Let's call it df2 actually. pd.dataFrame, and we pass in data 2. And if we want to take a look at df2, we have our data frame. You can also create a data frame from a 2-dimensional NumPy array by specifying the column names. So let's create an array of data. And here we're going to use the NumPy library to create an array. And here we're going to pass in basically a list of lists. So let's say 5, 3, 1, 2. It's going to be 1. Then we're going to have 4, 3, 1, 2. Except with spaces, comma, and then finally, let's say 6, 3, 5, 2, all spaces, there. Now let's create our column names. So let's create the columns variable list, and let's pretend that these values are going to be specific parameters for flowers. So basically the length, the width of different types of flowers. So let's say this is going to be the SEPA length, then the SEPA width, except in quotes, then petal length, and last but not least, petal width. Okay. And then once again, we create our data frame. Then pd.dataFrame, we pass in the array data, and columns, we use the columns parameter, and we pass in the columns list of names. And so once we want to take a look at the data frame, we have the name of each column that we have created and the values for each specific column. You can also create a data frame by combining multiple series objects as well. So let's create this example of, let's say, stocks and their values. So let's say we have Apple stock, and this is going to be our series. So we're going to create pd.series. And here we're going to pass in list of values, just some random values, so 150, 153, and 155, where the index are going to be basically dates. So let's say 2021 0901, and let's just copy this. And this could be 02 and 03. And we could just copy this to make this a little bit faster. And let's say this is going to be now Google stock, and it's going to be valued at 2800, 2825, and 2850. And the dates, of course, we're going to leave the same. And then now we could create our stocks data frame. And again, pd.dataframe. And here we're going to use a dictionary, basically, where the Apple key will have the Apple stock, and the Google key will have Google stock. And if we want to take a look at our stocks data frame, and then there we go. So we have our series that we have created for each Apple and Google, and now we have converted that into a data frame. Now, there are various ways that you can manipulate data frames. You can, for example, add a new column to a data frame by assigning a series or list to a new column name. So, using our stocks data frame, for example, let's say we want to add a market cap column. So we have stocks data frame, and so we basically create the new column, which is going to be market cap, and we basically access it just like a dictionary. So imagine like this is our dictionary, and we provide the key that we want to add, and to that we add basically a list of values, which is going to be the column that we're adding to this data frame specifically. So let's put some random numbers. Obviously this isn't true, but let's say 25, 250,000, 255,000, and let's say 260,000. And if we take a look at our stocks data frame again, then we see we have added our market cap column here. Now you could also remove a column from a data frame, and to do that you could use the drop method with the axis equals 1 parameter. So let's say we now want to remove this market cap column. So what we would do is stocks df, and we want to assign to that the version of the stocks df where we drop the specific column name, which is market cap, and axis equals 1. So basically meaning that we want to remove this column entire. And so once we take a look at stocks data frame again, we see that we have removed the market cap column. You can access columns and the data in that column using the column name. So let's say we want to take a look at the Apple column and the values that are under this column. So we'll just do stocks df, and similarly, like with dictionaries, we will just provide the key value, which would be Apple here. And when we do Shift Enter, then we have the values for that specific column along with the indexes that were assigned to it. If you would like to access the rows, then you would have to use either loc or iloc methods. So if we want to say we want to use a specific index that we want to access, let's say the row of information that we want to get is from our stocks data frame, and we use the lock method. And here we want to get the row of the specific date, let's say the 2nd of September. So 2021 09 02. And then if we want to take a look at that row, we get that specific row, which is 153, 280, 25. So it's this one exactly. But if we want to get, rather than instead of by the index, but let's say the second row, then we will use the iloc method. So let's create a new row here. So row, let's say it's going to be, let's say we want to access the first row. And of course, indexing starts with 0. So to get the first row, we would use the 0 index. So we would do stock data frame dot iloc, and we would pass in 0 for the first row. And if we want to print out that row, the first row is 150 and 2800. I don't know how that got moved there, but yeah, so this is the first row using the iloc method. Become a member at AILearningHub.io and get access to personalized mentor guidance, early access to AI resources, help with AI projects, and a great learning community.